Every photon that reaches our telescopes has made an extraordinary journey through the vastness of space and the passage of time. Thanks to highly sensitive measuring instruments such as the James Webb Space Telescope, we are now able to see a more complete and deeper view of the universe than ever before. What we see in the depths of space is nothing short of astonishing, yet increasingly mysterious. These structures, vast clusters of galaxies, shining stars, and luminous cosmic nebulae, tell a story, but it's one that remains largely unknown to us. Even as we push the boundaries of our understanding of space and time, we are finding that the universe is far stranger, more complex, and more beautiful than we ever imagined. We are now looking farther into the cosmos than we ever thought possible. But instead of simple answers, we are finding only more questions. Instead of a definite boundary or limit to the universe, we find an ever-expanding void that stretches far beyond what our minds can easily grasp. This endless ocean of creation stirs within us a profound curiosity and deep wonder. However, the vastness of this cosmic mystery begs the question, why does the universe exist at all? How big is it, and what role do we, as inhabitants of one tiny planet, play in this grand design? As we ponder these profound questions, we turn to the wisdom of one of the greatest minds in physics, the late Stephen Hawking. He famously argued that the universe did not require a divine creator to exist. In his view, the universe was an astonishing creation capable of sustaining itself. Still, Hawking left open the possibility that the universe might be governed by some intelligence far beyond our comprehension. His words invite us to appreciate the universe for its immense beauty, its order, and its precision, suggesting that these elements could not have arisen by mere chance. Hawking's perspective challenges us to think deeply about the very nature of existence. Is the universe a product of chance, or is it the creation of something far greater? In the past, scientists believed that through mathematical formulas, rigorous calculations, and theories, they could explain everything about the universe down to the smallest details. However, as we delve deeper into space and time, our findings only seem to shatter our preconceived notions. The universe is more complex, more mysterious, and more mind-boggling than we ever anticipated. This sense of mystery is not a new feeling. Centuries ago, people struggled to accept that the Earth was not the center of the universe and that our planet itself was just a small sphere floating in the vast expanse of the cosmos. We are once again faced with the need to adapt our worldview, not to the shape of the Earth, but to the overwhelming complexity and seeming boundlessness of the universe around us. Today, scientists are forced to accept that we may never fully understand the true extent of what exists beyond the limits of our current vision. While we can observe the universe, we cannot definitively prove how or why it came to be, or if there is a greater purpose behind its existence. For now, all we can do is marvel at its wonders, study its components, and attempt to answer the most profound questions using the tools at our disposal. One of the most crucial aspects of our exploration of the cosmos is light. Light has been our guide and messenger, carrying with it valuable information about the universe. Through light, we can see and experience distant stars, galaxies, and nebulae. We can measure and observe them in a way that would otherwise be impossible. The speed at which light travels, at a constant and unchanging pace, allows us to peer back in time, all the way to the beginnings of the universe itself. Today, the mirrors of our telescopes are illuminated by light that has traveled from distant stars and galaxies, some of which existed long before the Earth was even formed. Photons, the fundamental particles of light, are like cosmic messengers. These particles not only provide us with images of distant stars but also with vital information about the movement, composition, and evolution of these celestial objects. Imagine the universe as an ocean, vast and infinite, where every ray of light reaching us from the farthest corners of space carries a message from a time long past. The light we see from the most distant stars and galaxies has been traveling for over 13 billion years. It began its journey at a time when life on Earth did not exist, and by now, the stars that emitted this light may have long since burned out or collapsed. Yet, thanks to the remarkable properties of light, it continues to reach us, unaltered and undeterred by the vastness of space. Because light can travel through space and time without changing much, it serves as a time capsule, allowing us to observe the universe's past in ways that are simply unimaginable. When we look at the light that has traveled more than 13 billion years, we are essentially peering back into an ancient time, observing the early stages of galaxy formation and the birth of stars. We can see the universe as it was long ago, before the Earth or even our solar system existed. This unique capability allows us to glimpse into regions of space that tell the story of the universe's past, and it gives us a sense of the immense scale and deep history of the cosmos. Currently, we can observe objects in a radius of about 46 billion light-years in all directions, which means that we have a view of the universe that spans a cosmic globe with a diameter of around 92 billion light-years. However, even this seemingly vast field of vision represents just a small fraction of what might truly exist in the universe. The space beyond what we can observe may be far larger than we can even comprehend. The more we observe, the more we realize how little we actually know. We have no way of knowing if there is a boundary to the universe or if it stretches on infinitely. The universe is constantly expanding, pushing the limits of our imagination and understanding. The expansion of the universe is often compared to the continuous movement of ocean waves. As galaxies drift apart, space itself stretches, and we are constantly discovering new phenomena that challenge the models and theories we have worked so hard to develop. New waves of discovery appear all the time, and with them come fresh insights into the nature of space, time, and the forces that govern them. However, just like ocean waves, the full extent of the expansion is difficult to grasp. We follow one wave of discovery and leave another unexplored. Yet, we continue to search for the connections between these waves, looking for clues that will help us better understand the ever-changing nature of the cosmos. With the arrival of the James Webb Space Telescope, we now have a view of space that is deeper and wider than ever before. This telescope is like a navigational instrument that helps us find our way through the vast and unpredictable waters of the cosmic ocean. Imagine peering into the sea with an underwater telescope from the coast of an ocean. You might be able to see reefs, rocks, open water, and perhaps a few islands. But the true extent of the sea, its true nature, remains beyond your sight. Similarly, with our telescopes, we can observe some parts of the universe, but how far can we really see with any man-made technology in an infinite expanse? We may be able to describe some of the wonders of the universe, but to fully explore every corner is beyond our reach. Our understanding of the universe is analogous to the way early explorers such as Columbus came to understand the world and its vast oceans. They discovered new continents, sea routes, and the shape of the Earth, things that were previously unimaginable. Today, when we can finally travel through space and see the cosmos firsthand, we will have a clearer understanding of what truly exists beyond the Earth. Until that time comes, however, we can only guess, study, and attempt to unravel the many mysteries that remain hidden in the vastness of space. It seemed, for a moment, that our understanding of the universe was solidifying into something coherent. We had an established model that began with the Big Bang, followed by a rapid expansion known as inflation. This expansion eventually led to the formation of the first accumulations of matter, which gave rise to the stars and galaxies we observe today. We thought we understood the processes behind the birth of stars and galaxies, how dust disks and gas clouds coalesce under the force of gravity to form stars that shine with incredible intensity. For billions of years, these stars would continue to shine, fueling the formation of even more stars and planets. But then, just as we thought we had a solid grasp on the universe, new discoveries began to challenge everything we thought we knew. It became clear that the universe was more complex than we had imagined. Stars are born, live, and die, but their remains, supernova explosions and black holes, continue to shape the cosmos in ways that defy our understanding. These phenomena are just the tip of the iceberg. The universe is home to countless stars, galaxies, and nebulae, but the true scale and complexity of these structures remain largely beyond our understanding. The discovery of dark matter and dark energy, concepts that we still don't fully understand, further complicates our model of the universe. In particle accelerators like the Large Hadron Collider, LHC, in Geneva, scientists are searching for the fundamental particles that make up the universe. Yet, for all our technological advancements, we are still far from discovering the answers to the most fundamental questions about the nature of reality itself. The James Webb Space Telescope, hailed as a milestone in the exploration of the universe, was supposed to be a tool that would unlock the secrets of the cosmos. Researchers hoped it would provide insights into the era shortly after the Big Bang, helping us understand the formation of the first galaxies and stars. But what they've found so far is nothing short of surprising. The facts they have uncovered do not align with their predictions. The universe, it seems, is still full of unexpected twists and mysteries waiting to be unraveled. In our ongoing quest for knowledge, we have turned to new methods of exploration. One of the most fascinating developments in modern astrophysics is the study of cosmic microwaves, a faint afterglow of the Big Bang that permeates all of space. This cosmic microwave background radiation is one of the most important clues we have about the early universe, and it provides invaluable insights into the origins of our cosmos. But even as we uncover more details, one thing becomes clear: the universe is far more complex than we can possibly understand. As we look into the deepest parts of space, we also find that we are looking into the past, millions and billions of years ago, to a time long before Earth existed. We are seeing a snapshot of the universe in its infancy, a universe that continues to grow and evolve in ways we are only beginning to comprehend. At the end of the day, perhaps the most remarkable thing about the universe is how little we truly know about it. The more we discover, the more we realize that there is still so much more to learn. The universe is not just a collection of stars and planets, it is an intricate, ever-changing tapestry of space, time, energy, and matter. It is a place of wonder, a place of endless mystery, and a place where humanity is just beginning to scratch the surface of understanding.